We were talking about the PCB of Fujitsu and O General Mini Split air conditioners, 1-ton models, and we've already discussed a lot about them here. But today, we will talk about the microcontroller and the low side of the PCB. I have already explained the high side and its SMPS in previous videos. Now, let's talk about when you are getting 5 volts and 15 volts here. Most of the time, issues rarely occur on the low side, but there is a possibility that your sensor is not working, your display isn't functioning, or the swing motors aren't operating. The switches may not be turning on. All these components also need voltage to operate, and these operations are managed by the low side, which directly controls the microcontroller and all these components. This is done with the help of the ULN3 IC, which acts as an assistant, while the microcontroller receives all the feedback and then runs everything. Now, we need some voltages in specific places to operate these components, and if these voltages are not present, everything will be disabled and won't function. I'll now tell you where the voltages should be present so that we can identify where the fault lies. Here, you can see Q3 written, and there is also Q2 present. There shouldn't be any voltages here, it's only attached to this, and the voltages generated here are formed on pin number 1. At this point, there should be 15 volts. If 15 volts is not present here, the blower motor will not work, and the error will be displayed on the screen. Now, look at resistor number 21. On this side, there should be 5 volts, and this is a 10 kilo ohms resistor. If 5 volts is not present on this side, you can assume there is a problem here, and you'll need to check the 5-volt line to find out what the issue is. If 5 volts is still not present, the blower motor will remain disabled, and the PCB will show an error on the display. Now let's talk about the EEPROM. You can see an EEPROM is installed here. The pin number 1 on this IC is located on the upper left side. We should get ground on pin 5, and pin 8 is VCC, where we should get 5 volts. If 5 volts is not present here, the EEPROM won't work. Your microcontroller may turn on, but it will show an error. Additionally, you can see capacitor number 36 here, where we should also get 5 volts. There's also a resistor, and we should have 5 volts there as well. If 5 volts is being generated, the system will keep working. Now take a look at resistor number 55, which is a 10 kilo ohms resistor. We should also get 5 volts here. If 5 volt is present, it means the system will continue to function properly. Now, let's talk about the microcontroller since it's installed here. I'll tell you at which points the required voltages should be present for the microcontroller to function. You can see that on pin number 48 and 47, there should be 5 volts. Similarly, to operate the microcontroller, there should also be 5 volts on pins 24 and 23. If any of these points on the microcontroller don't have these voltages, the system will not work, and the microcontroller won't turn on. If it doesn't turn on, the entire PCB will not function. Now, let's talk about the ULN2003. The ULN2003 is the helper of the microcontroller, which operates all further functions. But before discussing it, let's talk about its sensors. We will remove the sensors first. Look, I've removed one. Now, observe that its right side is pin number 1. On pins 1 and 3, we should have 5 volts. If 5 volts is present here, both sensors will continue to work. However, if for any reason 5 volts is not present, then one of the sensors will stop functioning. Now, let's discuss the ULN2003. The ULN2003 requires 12 volts to operate, but in this PCB, we only have 5 volts and 15 volts available, and there is no 12 volts at any point. Therefore, 15 volts is sufficient to operate it. Now, let me tell you where the required voltages should be. This is pin number 1. At pin number 8, we should have 15 volts, while pin number 9 is grounded. This way, we should get 15 volts, and then the ULN2003 will become functional. Now, let me explain its primary function, which is to switch on the relay that sends power to the outdoor unit. Look here, this is pin number 1, and it should have 15 volts. The microcontroller will give a command to pin number 6 of the ULN2003, and the signal will come out from pin number 11, which will ground at pin number 2. Once the circuit is complete, the relay will turn on. Now let's talk about the swing motor. Look, connector number 5 is used for this purpose. It attaches to the motor. Here, the ULN2003 has pins 2, 3, 4, and 5. When we turn on different functions, the microcontroller sends commands to these pins, and the output comes out at pins 13, 14, and 15. This process activates various functions, and the swing motor operates from this. Finally, let's discuss the display. The display also requires power, so we need 5 volts here as well. When 5 volts is supplied, the display will turn on. The red wire represents 5 volts, and wire number 6 is ground. Both should have 5 volts. If 5 volts is not present, the display will not function. In this way, if you ensure all these voltages are available and replace any damaged components, you can easily repair this PCB. I hope you enjoyed today's video, and I believe it will be quite helpful for you. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.